anything that's moving stuff around where you've got tracks involved or you've got stuff that's trying to align, go along something, these track rollers are going to be very popular. I'm Pat Courtney with JTech, and we're going to learn about track rollers, also known as cam followers. So why are they called track rollers? Why are they called cam followers? So popular applications for these two include riding on a track. So this cam follower will actually ride on a track like this, and it rides on the outside of it. Or it might ride up against a cam. So if you have a cam device, the track roller will be riding up against that cam, and it'll create this oval movement, if you will. So that's where the name comes from. So they are popular for those two type of applications. But they're used in several other types of applications as well. So what's unique about a cam follower? What is it? So, well, what's unique is it has this very thick outer race. So the cam follower is the only bearing that you can ride on the outside of it. So this thicker outer race allows you to ride on the outside of that race. And there's basically two types of cam followers. You have what's called a stud type, which is obvious. It has this stud, which is threaded. It also has a hole drilled in it so you can lubricate it. And then there's what's called the yoke type. And the yoke type just means it has a hole in it. So it's kind of like a normal, looks like a normal bearing, but it still has that thicker outer race. Now, what would you do with this one is you'd actually supply your own bolt. So you would just get a bolt with threads on it and put it through that hole. So this outer race is going to be made from 52100. The rollers are going to be made from 52100. Okay, but this stud is going to be made from 8620. This stud also includes the inner ring for this part. Now, why do we make the stud from a different material than the outer race? The 52100 material can be very brittle, so it can break if it's put under stress. So the weakest part of a stud type cam follower is right here in this corner. And so if you put a whole bunch of force, or if you put a whole bunch of weight on this, you can crack that stud right here at that corner. So this 8620 material, what it does, it has a softer core. So it actually will flex a little bit. It won't fracture, especially on an impact. So if we hit this cam follower real hard, if it's 52100, it might fracture right at that corner. The 8620 material is more forgiving. So it doesn't necessarily have a higher fatigue load limit, but it has a higher static impact load limit. So now, these cam followers are typically, you can see inside this one, we don't make it with a plastic, we make it with metal, with 52100. But you can see the needle rollers inside. This is a full complement where there's no cage. We make it both as a full complement or as a caged product. Now, the nice thing about these cam followers, you can get them with seals on it. You can also get what we call a controlled contoured outer race. So we can actually curve this race, this part where the cam follower sits on the surface. And that allows us, if this thing is misaligned a little bit, that curved race helps us share that load better with the rollers that are inside. So having that little bit of a curved race allows for better misalignment capability. Now the end of the stud, you see this hex hole here. This is a hex socket or an Allen wrench socket. You can also, the standard version is a screwdriver. And what are those holes for? Well, that's for holding the cam follower while you're tightening the nut on. So you can either use an Allen wrench or you can use a screwdriver. The Allen wrench is the upgraded version. Now you can also get these with what we call a heavy duty stud. So a heavy duty stud is we make the stud a lot bigger. So this part of the cam follower is still the same size, but the stud is thicker, and that helps again with avoiding breaking that stud if you have a high shock load or you're putting too much load on it. Now this stud can also come with what we call an eccentric, and the eccentric looks like this. You can see that's not round, it's got the eccentric. So we use that eccentric, so once this is inside the frame, we can use it to adjust this product up and down so it sits on the track flat. So if the hole we have drilled here, where this hole that it's going through into a frame, is a little bit off, we can adjust with this eccentric to move this thing vertically so it sits flat on the track. So it's sitting flat down on that track. Cam followers, the stud type, are also relubricatable. So they have this hole drilled in the end, which actually goes all the way to underneath the rollers and then comes up, and you can relubricate those. Now, the yoke type, obviously you cannot relubricate that. So there's no way to relubricate this product. Once it's greased, it's ready to go. So what are the size ranges for this product? Anywhere from a 1/2 inch OD. Now we're talking about the OD. Most product we talk about the bore, 1/2 inch OD to about a 6 inch OD. So we make some very large cam followers. And on the metric side, anywhere from a 10 millimeter OD to a 300 millimeter outside diameter. Now, again, like your needle bearings, like your drawn cup and your solid race product, these can only take radial loads, and they're designed to take high radial loads. No thrust loading. So we can't push on this shaft or this stud. We can't push on it from the side and put a thrust load on these rollers. The bearing's not designed to do that. It's only designed to take a pure radial load. These aren't used for high-speed applications. As you can see by the full complement design, with all those rollers rubbing against each other, this is usually designed for slow-moving track-type applications, a few hundred RPM, maybe 1,000 RPM, but not very fast. Again, we're riding on the outside of the bearing, so that kind of limits our speed as well. Why use a track roller? Again, high radial loads, very small cross-section. That thicker outer race allows us to ride on the outside of the part. So what makes a track roller or a cam follower unique is that thicker outer race and that ability to ride on the outside of the part. What also makes it unique is the stud, right? None of the other bearings have an actual stud that you can mount and put a nut on to install it. And it's very easy to install. You stick it through a hole, put a nut on here, and you've got a bearing that's going to ride on the OD. Wide breadth of product. So not only do we make this an inch product all the way up to a 6 inch, but we also make it in metric product as well. Available with seals. The stud type can be relubricated. We can put a crown on that OD or that controlled contour on the OD to help with misalignment. Where are these cam followers used? Well, a lot of them are used in forklift trucks and scissor lifts, tube bending equipment, canning equipment, security gates. Again, conveyors, food processing equipment. You're going to see a ton of cam followers and food processing equipment, automated manual handling equipment. Anything that's moving stuff around where you've got tracks involved or you've got stuff that's trying to align, go along something, these track rollers are going to be very popular. The really large track rollers are used for moving really heavy pieces of equipment. So in summary, the track roller is the only bearing designed to ride on its OD. It takes high radial loads and has a very thin cross-section, wide breadth of product in inch and metric, and it can be sealed and relubricated. Thanks for following along as we roll down this track, learning about cam followers and track rollers. Stay tuned for more bearing training from J-Tech, formerly known as Koyo.